Good morning, sir. Myself, Shivraj Singh, Assistant Professor in Electronics and Communication Department, SIRT Bhopal. Today, we'll be discussing about the LTI system, which is used in a signal system. LTI system stands for Linear Time-Invariant System, which is the basic concept of the fundamental of signal processing and control system. LTI system are those systems which is satisfy the linearity and time invariant property. That is called LTI system. LTI system basically has a linearity property. That means it has additive property and scaling property. According to additive property, in which the n number of signal in terms of continuous or discrete, they are additive. That means addition nature. And the scaling property, that means if we multiply any constant, then the response equal to the constant multiplication and input signal. That means linearity property when the system output of the linear combination of input match with the output of the linear combination of the each input response separately. The system said to be a linear system. First one, linear system satisfy the superposition principle, जो already discussed, that is additive property. If signal input x1t give the output y1t and another signal x2 of t give the output of the y of t, then the according to superposition principle, x1t plus x2t give the output of the y1t and y2t. Second one, homogeneity property, that means scaling property. If input x of t give the output y of t, then according to scaling property, a into x of t give the output equal to a into y of t. That means scaling factor multiply with the input signal. After combination of additive and scaling property, the combined property give the linearity property. That means according to linearity property, response of the combination equal to the response of the addition of the response of the individual system. That means AX1T plus BX2T equal to AY1T plus BY of T. Second one, LTI system satisfy the linear time invariant property. Time invariant property. That means time invariant invariant system are those whose the output is independent of timing of the input application. That means the input output characteristics of the LTI system does not change with respect to time. According to time invariant property, a system is time invariant if the behavior of do not change over the time. According to this property, if input x of t equal to y of t, then delay the input as well as output. So according to time invariant property, input x of t minus t naught equal to y of t minus t naught. So shifting the input simply shift the output by the same amount. Why we are use LTI system? So LTI system are important because they are easy to analyze the mathematically. Second one, predictable and stable in many cases, described completely by the impulse response. According to impulse response, which is generally represented by the convolution integral, yeah, convolution summation. So for continuous time system, the convolution of according to convolution, the output of the LTI system given by the y of t equal to x of t convolution of h of t. Type of LTI system. According to signal, there are two type of LTI system. First one, continuous time LTI system. Continuous time LTI system. In continuous LTI system operate on the continuous time signal x of t, often described by the linear constant coefficient differential equation. In this block diagram, we can show that here the input signal, that is output signal, and this block represent the LTI system, that is H of t. The output of the continuous LTI system given by the mathematically expression this one, that is y of t, convolution of x of t and h of t. So y of t equal to minus infinite to plus infinite x of tau h t minus tau into d tau. Next one, discrete time LTI system. Discrete time LTI system basically operate on the discrete signal, that is x of n. According to LTI system, mathematically the output of the discrete LTI system given by y of n equal to x of n, convolution of h of n, and mathematically it is represented by this one, that is y of n equal to summation of k goes to minus infinite to plus infinite x of k into h n minus k. This h of t represent the delay factor by the k unit. Next one, transfer function of the LTI system. Basically, LTI system represented in terms of uh, uh, transfer function or system function. Basically, transfer function or system function are represented by, with the help of Laplace transform, Fourier transform for continuous time signal, and similarly for Z transform used for the discrete time system. So, according to the transfer function of LTI system in continuous nature can be calculated by the Fourier or Laplace transform. LTI system transfer function can be only defined with the zero initial condition. For simplicity, if we can calculate the Fourier transform or Laplace transform, so firstly assume the zero initial condition for this one. In this block diagram, here the input and output, this is the LTI system, which is represented by h of t in terms of Laplace transform h of s, input signal x of t, or in terms of Laplace y of s, output signal y of t, or in terms of Laplace transform y of s. Mathematically, in Laplace transform, the transfer function or system function is given by y of s upon x of n. In terms of Fourier domain, that is Fourier transform, which is represented by h of omega equal to y of omega upon x of omega. Now, the transfer function of the discrete time LTI system. A discrete LTI system transfer function can be defined by the Z transform. Here the input signal x of n, this one y of n, that is LTI system in discrete nature. Then the transfer function or system function given by h of z equal to y of z upon x of z. Property of the LTI system. The LTI system has the many property. First one, linearity property. A system is a linear if satisfy the superposition principle. That is, a x1t plus b x2t equal to a y1t plus b y2, where a or b are the unique constant value. Second one, time invariant property. If x of t represented by y of t, then the delay the input by t naught unit, then x of t minus t naught, that produce the output y of t minus t naught. That means in time invariant property, the input output characteristics do not change with respect to time. Third one, causality. A LTI system said to be a causal system which depend only on the present and past value or input. Condition for causality h of t equal to 0 for t less than 0. That means a system if define only the positive value of t. For negative value of t, the impulse response of the LTI system must be equal to 0. Fourth one, stability. The stability of system represented by with the help of BIBO stability. That means bounded input, bounded output. A LTI system is stable. Every bounded input give the bounded output. This is the condition for the LTI system. For stability in terms of continuous time signal, this is represented by minus infinite to plus infinite mod of h of t dt less than infinity. And next one, convolution property. If the the output response of the LTI system represented by the convolution of h of t convoluted with respect to h of t, that means impulse response. Next one, memory. A LTI is basically a LTI system is a memoryless or static. That means its output depend only on the present input. Thank you. Thank you so much.